Project 2.9 Unpacked, the 595 shift register. This is the circuit built entirely using D flip-flops. As demonstrated, when the data input button is pressed, followed by the clock button, the data shifts into the circuit. The LEDs connected to the outputs of each flip-flop display the stored values in real time. Pressing the data button enters a 1, leaving it unpressed enters a 0. Each press on the clock shifts the new bit through the chain, simulating the operation of a standard shift register. This project is modeled after the SN74HC595 shift register, a widely used integrated circuit in digital electronics. The 595 is designed to take in data one bit at a time through a serial data line and store it internally through a series of flip-flops. Once stored, the bits are output in parallel across 8 pins, allowing for efficient control of multiple devices such as LEDs or displays using only a few microcontroller outputs. The 595 includes additional features like internal storage latches and an enable pin to help maintain stable output and reduce signal glitches. A D flip-flop stores a single bit of data and updates its output on the rising edge of a clock signal. When the clock transitions from low to high, the value at the D input is captured and held until the next clock pulse. The flip-flops are connected in series to form a shift register. The Q output of each flip-flop feeds into the D input of the next, allowing data to shift sequentially through the register. The D input of the first flip-flop is controlled by a push button connected with a pull-down resistor. Pressing this button delivers a logic high to the input, while releasing it returns the input to a logic low. This design allows manual entry of each bit in the desired sequence. To control timing, a 555 timer IC is configured in A-stable mode to generate a clean, single pulse on each press of the clock button. This pulse is distributed to the clock inputs of all flip-flops, ensuring a synchronized data shifting without the interference of a switch bounce or inconsistent pressing. A reset function is also included in the circuit. A push button connected to the clear inputs of all flip-flops sets each output to 0 when pressed. LEDs are connected to each Q output. These LEDs provide real-time visualizing of the binary data within the register. When a flip-flop holds a 1, a corresponding LED lights up. When it holds a 0, the LED remains off. Overall, this circuit effectively demonstrates the core function of a serial in, parallel out shift register and mimics the behavior of an SN74HC595 at a fundamental level. It provides a clear view into how digital memory elements operate, how data flow through sequential logic, and how clock-driven circuits can be used to manage and display binary information. This is Project 2.9 Unpacked, the 595 shift register. Thank you for watching.